two major programming styles. There are other styles, of course, but two major ones that are widely used in practice in terms of style of programming. There is functional programming and object-oriented programming. Okay, those are two major styles. There are other ones. So now, in functional programming, what are each of them have some principles and some mindset of how you approach the solution and how you organize your solution. So in functional programming, what are the main principles? Okay, so you decompose your solution into functions. So your program will become made up of functions. So basically, your program will be, this is your program, will be made up of functions. Function 2, function n. Yes? Now, in object-oriented programming, what is the decomposition unit?
Objects.
Objects. So your program will be made up of objects. Yes? Of course, these objects are instances of classes. So in terms of design, you design classes and then you instantiate classes from these objects from these classes. Now, let's start with functions. What is a function? Yes, please.
You can input and the processor comes out output.
Excellent. So a function is a unit of computation that does some computation. It takes some input, it does some processing, and returns some output. Yes? So I'm 100% sure you're already familiar with this. So what we have here in terms of syntax in JavaScript, this is the general syntax. It's a function, it takes some parameter and return some value. Now, in terms of syntax, there are three ways of writing a function in JavaScript. You can write it the traditional way. You're already familiar with this. You use the keyword function followed by the name, followed by parameters, and then the body of the function. At the end of the body, you return something. This is one style of doing it. The other style is you create a function that doesn't have a name, but you assign the function to a variable. And then you can use that variable to call the function. This is called anonymous function. It does not have a name. A more elegant way and more concise, more short way of writing a function is to use arrow functions. So I hope you already practiced this. This is the latest way and kind of the recommended way, especially for simple functions. Okay, now, as a functional programmer, yes, you decompose your code into functions, but there are some principles you need to keep them in mind for you to really comply with the functional programming paradigm. What are these principles that you should keep in mind when you are doing functional programming? A function, in terms of responsibilities or in terms of tasks the function is doing, how many responsibilities or how many tasks should I assign to a function?
One. Really?
One and only one. This is very important. A function is very specialized. It does one and only one thing. Okay, this is called the singular principle. Why we do this? Why this is very, very important? For two main reasons.
Complexity.
Reduce the complexity, very good, because as humans we are very good into focusing on one thing at a time. And also the results, the produced program will be more understandable and easy to maintain when it is broken down into smaller pieces, smaller chunks. You put in so much stuff in one function, you break down functions, and then you compose them to produce the desired results. Maybe, well, yes, one function might call many functions to do the work at the end, but the steps of the work is given to each function at a time. Yes, very important. Okay, what else? Why do we break down into smaller units? What's another reason besides making it easy to understand, easy to maintain?
In case we need to change anything later on in
Yes,
the future.
easy to maintain.
Maybe,
Yes, easy to maintain. But more importantly, more chances of being reused. If you have something very specialized, you can reuse it more easily than if you have a function that does so many things. I want to use it, but it does things that I don't need, so I'm not going to use it. Okay? So it encourages reuse, and this is a very important principle. So it is maintenance, it is understandability, and gives us more chances of reusing those functions. So this is the first principle. The second very important principle is this is singular functions. The second important principle is that the function should not change the input. And it should not rely on global variables. This is very important. What I mean by this, I call a function. It should do its work using the input I gave, but it should not touch my input. The input should be unchanged. Sorry?
It's a number that
It takes some input, not necessarily a number. It could be a list, it could be a string, it could be whatever it might be. It doesn't manipulate. It uses the input, but doesn't change the input. It produces a new data without changing my original one. And this is very important to make it easier to test. And also, I can make the work done in parallel. Like I can run functions in parallel, especially that we have GPUs and we have CPU with multiple cores. I can safely run the function in multiple instances of the function in parallel. And it is safe because each function will do its work and return me a different, a new data without changing the input. Okay? So let me show you some of the functional programming features and principles, particularly in JavaScript. So the first thing in JavaScript feature that we have is anonymous functions, or we also call them lambda functions. So an anonymous function is a function without a name. This is one of the features in JavaScript. And I can take this function and assign it to a variable. Then I can call that variable. Sorry, I can call the variable by, let's say, doing square 4 and give me 16. So another way of writing it is you're writing it as a lambda expression. So this is one of the features of JavaScript, and I can make use of this feature as we go, especially this one. So whether I define it using the old syntax or the new syntax, at the end of the day, what is the type of this variable I have created? It is a function. Okay, so the second feature in JavaScript, this is it takes a bit of time for you to get convinced and to really kind of embrace this new concept. We call this, in JavaScript, functions are first-class citizens or first-class concepts. What we can do with functions? We can store them in variables. I just showed you. What I did here, I created a function. What I did with this function, assign it in a variable. This is a bit strange because you have not seen this before in JavaScript, in Java or in C++. In JavaScript, this is fundamental concept. I can take a function and assign it to a variable. I can pass a function as a parameter to another function. You have seen this in a map. For example, to process arrays, I have array.map. A map is what? Is a function. And what it takes as a parameter? Another function. Not only this, a function can return other functions. So a function is nothing but similar to a value, similar to a variable that's hold the value. Whatever I can do with normal variables that we are familiar with, I can do with a function. I can store it in a variable, I can pass it as a parameter to another function, and even a function can return another function. This is very widely used in JavaScript. Don't be scared of it. You will get familiar with it as we move, but this is very normal. So here is an example. For example, what this first statement is doing. Yes, it's creating an array of functions. You can be as crazy as this. Okay, so I'm creating an array of functions, and here what I'm doing. Yes, sorry. So what I'm doing here?
Using the function
Calling which function?
map function
The one at
number one.
with the index 1, which is basically the second function. I'm calling it and passing the parameter 3, and this is the one will be called. 3 times 3, I'll get 9. But in general, you learn the features of the language, and you try to make a reasonable and best choice of what feature you will use for which scenario. But for now, at least get familiar with these features, and gradually you will see scenarios where best to use them. Okay? But keep this in mind. This is new. These are new concepts. It will take a bit of time for you to grasp and start utilizing because you have not seen this before. This is very important. In JavaScript or in functional programming in general, one of the very important principles is to create pure functions. What is a pure function?
A function that does nothing with the data.
Nothing with the input data.
Yeah.
So the input data, we call it immutable and changeable. It takes the input, it does some work, and it returns some output. It does not change the input. That's basically. It doesn't. In general, we call it does not have side effects. You can call it safely. You can call it as many times as you wish, safely without changing your input. So for example, a bad programming style that does not use pure function, what it does, it creates some variable, and then it lets multiple functions read and write to it. And when something gets, when something happens, like some corruption or unwanted change to the data, you don't know who to blame because you have this shared data. So pure functions try to avoid this. How do we avoid this in pure functions? So basically, one function does some work, return an object, return some output, and then we take that output and we pass it to another function. That function does some work, returns some other output, and we take that output and we pass it to another function. Pure functions, in simple definition, what is the pure function? Simple definition, it does not touch the input. That's it, okay? And also, we don't use global shared variables between functions. If I want to pass something to the function, I don't tell it, oh, by the way, go and get it from this variable. I don't do that. I pass explicitly the input to the function. The function does not depend on anything else except the input. This is what the definition of pure function. It does not depend on global variables. Okay? So basically, that is the idea. You will appreciate this as we move forward. Okay, singular function, I already explained it, one and only one task. And then what I can do when I have a bigger task, I can chain those functions. I can compose them to do more complex tasks. Okay, I already explained this principle here, high order functions. So this you will see all the way as we move forward, that we use a lot of high order function. What high order function means? That a function can be passed as a parameter to another function. You already seen this with map and reduce. A function can also return another function. This is an example. This is an example. Have a look at this. Have a look at this. So what I have here, a function called multiply by, and I give it a factor. Yes? And then what this function does, it returns another function. This function, it takes another input, and what it does, it multiplies that input with the factor that I have supplied earlier. This is the example usage. This is an example usage. Now, if I call this function and give it 10, what it will give me? It will give me another function that is able to multiply the input by 10. So basically, when I call this, I get another function. And then I can take this and call it again. Because it is a function, I can call it again. So the result will be, for example, in this case, if I call this function and pass 10, I will get a function that is able to multiply the input by 10. Then when I call it, it will multiply my input by 5, and I will get 50. Now, you might not be convinced with this, but in here it becomes very, very useful. So what I'm doing here, I'm taking each of those inputs and multiplying them by 10. By basically passing this multiply by. What this multiply by will do? Will return a function. And then what do I do with that function? I pass it to map. And what map will do? Will visit every element and call this function. So this is just an example. You might not be able to use it so far or to see how to use it, but at least be familiar with it. That a function, I can pass it as a parameter, and I can also return it as a return from another function.